All right, the last type of naming that we need to go over is hydrates. Remember that hydrates are ionic compounds with water attached. So you still have to know your ionic naming rules. Remember that that's when you have a metal and a non-metal. So you have something on both sides of the stair step, or more specifically, you have a cation and an anion. You have a positive charge and a negative charge. And then you have some waters attached. So we use our ionic nomenclature to name the ionic compound, and then we use a prefix and the word hydrate to represent how many waters are attached to that ionic compound. So let's look at some examples. COCl2 dot 6 waters. That dot there does not mean to multiply, it simply means that waters are attached. So CO is cobalt. Now cobalt happens to be a transition metal because it's in groups 3 through 12. So we're going to uncross our charges to figure out the charge that's on the cobalt. So we would bring up that subscript, and then the subscript here is a 1, so we would bring that up. Chlorine is a -1 because it's in group 17, which means the charge on the cobalt is 2. So this is cobalt 2, and then Cl is chlorine, so we would change the ending to chloride. Cobalt 2 chloride, and then we use a prefix to represent how many waters are attached. And so the prefix for 6 is hexa, and then the word hydrate to represent water. So cobalt 2 chloride, hexahydrate. Let's look at another example. BeSO4 with 4 waters attached. So here we have more than 2 capital letters, which means it is a polyatomic. So we're going to need page 7 of the reference tables. And we would see that SO4 is the polyatomic. Be is beryllium. And then SO4 is sulfate. And we don't change the ending to polyatomics unless it's a part of an acid. Beryllium is not a transition metal, it's in group 2, so it doesn't need a Roman numeral. 4 is tetra, and then hydrate for the water. Beryllium sulfate, tetrahydrate. All right, let's go the other direction. Remember, we have to cross our charges unless we see prefixes in with covalent compound or covalent elements. So here we have sodium sulfite. The ITE is telling you there's a polyatomic. So sodium Na is in group 1, so it has a charge of +1. Sulfite on page 7, SO3 2 minus. And then we're going to cross our charges. So we'd bring the 1 down, we would bring the 2 down. So we have Na2 SO3 dot, so we can show the number of waters attached, and then we look at the prefix in front of hydrate, hepta. Hepta is 7, so we have 7 waters. So Na2 SO3 7 H2O. Let's look at one more. Copper 2 sulfate. So copper has a charge of +2 because of the Roman numeral there. It's a transition metal, so we have to be told. Sulfate ends in ATE, so it's a polyatomic, so we would say SO4 2 minus, coming from page 7 of our reference tables. And then we would cross our charges. So we would have Cu2, SO4 2. Now those 2's can be reduced, and so really copper 2 sulfate is CuSO4. And then we would have dot, and then the prefix telling us how many waters are attached is penta. Pent means 5, so 5 H2O.